Hello everyone, for this tutorial video, I'd like to explain how to use the substitution rule for definite integrals rather than indefinite like in the previous tutorials, and how there are two distinct methods, one using what we already know, the indefinite method, and one using changing the limits of integration to different values. For example, if we are asked to evaluate this integral, we can see the method using indefinite integrals is to see that u is on the inside of the square root. Change in u equals negative 12t squared times change in t. In conclusion, t squared times change in t equals negative 1/12 change in u. The integral simplifies to negative 1/6 integral of square root of u times change in u from point negative 2 to 0, as those were the points we were given in the beginning of the problem. We now evaluate this indefinite integral at the 2 points specified. Let's see first, because our range was in the value of t's, we cannot evaluate values of u for this. We have to plug back in the original function for u before we can do the evaluation. Once we do this, the arithmetic tells us the final result is 1/9 times 33 times the square root of 33 minus 1. But there is also a second method that involves changing the limits of integration, like this. We do the usual step of identifying the u and taking the change in u and multiplying by the change in t. But we also change the limits of integration from terms of t to terms of u by plugging in the value of u for the value of t given. So now we can integrate u over the u points specified, which would be in this case from 33 to 1. And we get the same answer as in the first method, which makes sense because, since we are evaluating the same exact original function over the same exact interval of integration, the final answer must be the same regardless of the method. In conclusion, we have seen we can use the substitution rule for definite integrals as well as indefinite integrals, and that there is the manual method, using what we know is true from indefinite integrals, and then there is the quick method, involving changing the limits of integration before finding our final answer. And both methods will give you the same answer, because it is the same integral regardless of how you tackle it. Now that we have discussed methods of computing integrals, we can discuss applications of integrals, such as finding the area and volume of irregular shapes, as well as finding the average function on a specific interval. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.